Hi, I'm Miss Hearn. Let's get started. In this video, I am doing a lecture for my intermediate algebra class where we're continuing our discussion about solving quadratic equations with a focus on the square root property and completing the square. So quadratic equations are equations that include an x squared. They can be rearranged to be written in the form ax squared plus bx plus c equals 0. But depending on the form of the quadratic equation and the situation, you might want to use various techniques to solve. The first technique we learned was the zero product rule. And according to the zero product rule, if you have a quadratic equation, which we do here, you can tell because of the x squared, even though it's missing the bx term that you would expect to see, just think of the b as being 0, so that term goes away. It's still considered a quadratic as long as it has that x squared in it. So we've learned that we can factor, and in this case it's factorable because it's actually the same as saying x squared minus 3 squared equals 0. Which means that it's a difference of squares, and difference of squares can factor into conjugates. So that would factor into x minus 3, x plus 3 equals 0. So essentially what we have here is two mystery numbers, x minus 3 and x plus 3. They're being multiplied together and we get 0, so we can use logic, reasoning, to conclude that if you multiply two unknown numbers together and get 0, one of them had to be 0. So that means that we can rewrite this quadratic equation as two linear equations, either x minus 3 equals 0 or x plus 3 equals 0. If x minus 3 is 0, isolating the x in this linear equation by adding 3 to both sides, we get that x is equal to 3. And in the other linear equation, we subtract 3 from both sides and we get x equals negative 3. So there are two solutions, 3 or negative 3. Another technique we can use for solving this same type of equation is called the square root property. So we're going to take a look at that today. The square root property can be used to solve any quadratic equations of this type where the bx term is missing. So you just have the ax squared plus c equals 0 situation. And what the square root property says is that if you have any number, any variable squared equal to a number, like x squared equals some number k, if it's true that x squared is equal to k, then it must be true that x is the square root of k. But, and this is the part that most people make their errors on, it's not just the positive square root of k that's possible. It could be the positive or the negative. This statement, if x squared equals k, then x equals plus or minus the square root of k, is called the square root property. So if I asked you to solve x squared minus 9 equals 0, the same equation we solved a minute ago, but solve it using the square root property, I don't want you to use factoring. I want you to use this idea. So I would expect that you would isolate the x squared in the equation by adding 9 to both sides, and that you would get x squared equals 9. And then you would from there be able to see that it matches up with this rule, that if x squared equals a number, then x is plus or minus the square root of that number. So you would say, okay, well that means that x is equal to plus or minus the square root of 9. And the square root of 9 is 3. So that would mean that x is equal to plus or minus 3. This plus or minus just means that you have two answers, a positive 3 or a negative 3. So you're going to have the same solution set, 3 or negative 3. So this is just a different tool in your toolbox that might be advantageous in certain situations. So First, I would like you to, if you're watching this video, pause the video and try to see if on your own if you could work these three equations. 1, x squared equals 16, 2, x squared minus 25 equals 0, and 3, 2x squared minus 40 equals 0, using the square root property. Then resume the video and take a look at the solutions. All right, here I've worked out items 1 and 2. For number 1, we had x squared equals 16. So by the square root property, that would mean x is plus or minus the square root of 16, which means x is plus or minus 4, because remember 4 squared is equal to 16. So that's why the square root of 16 is 4. But it could be the positive or negative version, so we get 4 and negative 4. For item number 2, we have x squared minus 25 is 0. Adding 25 to the other side, to both sides, we get x squared equals 25, which means that by the square root property, x is plus or minus the square root of 25. And since 5 squared is equal to 25, we know that x must be plus or minus 5. Now let's look at number 3. For number 3, we have 2x squared minus 40 equals 0. The first step in this process of getting x squared by itself would be to add 40 to both sides. And that would tell us that 2x squared is equal to 40. Before you apply the square root property, though, you still need to get rid of the coefficient of 2 in front of the x squared. Since the 2 is being multiplied by x, we have to divide by 2 on both sides this time. So that means we would get x squared equals 20. So if x squared is equal to 20, that would mean that x is plus or minus the square root of 20. Now, if you got that as your answer, you should give yourself a pat on the back, because that's definitely a lot of good work that you've done, but you're not quite finished. The square root of 20 is not completely simplified. Remember, to be a simplified square root, you can't have any factors that are perfect squares. What is a number that divides evenly into 20 and is a perfect square? Well, 20 is divisible by 4, right? So this is the same as saying x equals plus or minus the square root of 4 times 5. You can take the square root of 4, so in order to be considered simplified, you have to do that. Square root of 4 is 2, but you can't take the square root of 5, and in fact 5 is prime, so that's just going to stay the same. So your solution set should be 2 square roots of 5, negative 2 square roots of 5. All right, so these are all the 3 solutions to these 3 problems. Okay, now in my class we're working with ALEKS, and here's an example of a problem in ALEKS. And you'll see the topic is solving an equation of the form x squared equals a using the square root property. And in this case, it says solve v squared equals 49. So it doesn't matter if it's an x or any other variable. The square root property still applies. If v squared is equal to 49, then what must v be equal to? Now, if you said 7, you're half right, but you would get that problem wrong if you put that into ALEKS. In fact, there are 2 numbers that you can square to get 49. Either the positive or the negative square root of 49. So you would need to say plus or minus 7. So in ALEKS, you're going to submit both the answers 7 and negative 7. All right, so we've worked several examples of using the square root property. So your first classwork item number, if you're in my class, item number 1, remember, put this on a clean sheet of paper. You're only going to have the classwork items on the sheet of paper. Go ahead and try to solve x squared minus 24 equals 0, and then pause and we'll go over the solution. Okay, we're solving using the square root property. Notice that, in fact, we would have to use the square root property for this problem because it does not factor. 24 is not a perfect square. So it's a good thing we have this other option. So what you would do is you would isolate the x squared part by adding 24 to both sides. That's going to give you x squared equals positive 24. And then you're going to apply the square root property. Sometimes teachers say, think of it as taking the square root of both sides. I don't like to say that because I want you to remember that the square root property involves the plus or minus, not just taking a square root. At this point, you have to simplify the radical if possible. And in fact, this is another example of a number that is divisible by 4. 24 is the same as 4 times 6. So keeping that in mind, think of it as taking plus or minus the square root of 4 times 6. Square root of 4 is 2. So that would be plus or minus 2 times the square root of 6. By the way, I do have a video on simplifying square roots. So if you're having trouble with that, just search for that video. All right, so your final answer that you would put into the system would be 2 square roots of 6 or negative 2 square roots of 6. It doesn't matter the order that you put them in the set brackets. In a previous lesson, we talked about taking square roots of negative numbers, and this is going to come up in some of the equations that we're going to solve today. So I just want to remind you that if you have the square root of a negative, you're going to immediately change it to what we call I notation. The square root of negative 1 is I. By definition, I is the number that if you square it, you get negative 1. There was no number in our number system that had that characteristic, so we came up with a new number, or we determined that another number existed that we didn't have a symbol for, so we gave it the symbol I. So anytime you have a square root of a negative, you're going to take the negative out of the square root, and on the outside of the square root, you're going to place an I to indicate that there was the square root of a negative. So the square root of negative 37 is I root 37. If you haven't watched it already, there is a video about complex and imaginary numbers from the previous lesson. All right, so keeping that in mind, and let me work one more example. Let's say we had the square root of negative 25. So you would immediately change to I notation, no more negative under the radical, and then an I out front. And then the square root of 25 is actually 5. So this is I times 5, but we normally write 5I. All right. So now I would like you to try to solve x squared plus 24 equals 0. Go ahead and pause the video and see what happens, and then restart it, and we'll go over the solution. All right, so the first thing you would need to do is to subtract 24 from both sides, and then you're going to get x squared equals negative 24. Then by the square root property, that means that if x squared is negative 24, x had to be plus or minus the square root of negative 24. But then you need to simplify the radical. Since there's a negative under the radical, you're going to bring the I out front. Notice that the negative is no longer under the radical, but we still have that plus or minus out front. That is not affected at all by the negative inside the radical. And then you need to simplify the square root of 24. But we've already seen that the square root of 24 is actually 2 times the square root of 6. We just did that a minute ago. So now normally we like to put the whole number first, and then the I, and then the radical. So this is the order in which we generally see an imaginary or complex number written. And we're going to separate it into the positive and the negative version with this comma in the middle. So this is the solution set. Now remember, it's easy to forget that what our goal is here is to find the number x that makes the original equation true. And that in fact, any answers that we get, if we plug it back into that equation, it should give us a true statement. So let's just take a minute and check. Does it actually make sense to have that as our solution? So I'm going to check. I'm going to take, for example, 2i root 6, and I'm going to plug it into the equation x squared plus 24 equals 0. So that means I would be squaring 2i root 6 and adding 24 to it, and I want to know, does that actually equal 0? Well, when you square a product, it's the same as squaring each part of the product. So it's 2 squared times I squared times the square root of 6 squared, and we want to know, if you add 24 to that, do we get 0? Well, 2 squared is 4, and I squared, by definition, recall I squared was -1. So I squared is -1, and then square root of 6 squared, when you square square root, those operations reverse each other, so you're just going to have 6 plus 24, we want to know, does that equal 0? Well, 4 times -1 times 6 is -24, and if you add 24 to that, yes, you do get 0. And similarly, if we had had a negative in front, we would have just changed one thing. If you had x equals -2i root 6, then there would have been a -2 here. When we squared the -2, we would still get a +4, and it would still check. So yes, both of those solutions work. Okay, so we've seen that the square root property can work even if x squared is equal to a negative. There's also another situation where we use the square root property, and that's when we have a quantity in parentheses squared equals a number. So in other words, this problem here, problem A, we've seen something similar to this where we had just x squared equals 16 and we took the square root. But it also works even when there's a quantity in parentheses squared equal to a number. Remember, this is just a mystery number. This is just an unknown number. And when we square that unknown number, we get 16. So by the square root property, that must mean that x plus 3, the mystery number, is plus or minus the square root of 16. Now that would mean that x plus 3 is plus or minus 4. So we would now have an extra step though. We'd have to subtract 3 from both sides of this equation. So we'd get x is -3 plus or minus that 4. And you can't just stop here because these two are like terms. So we have to actually separate that out and say, okay, well, either x is -3 plus 4 or x is -3 minus 4. -3 plus 4 is 1. -3 minus 4 is -7. So your solution set would contain 1 and -7. All right, I'd like you to try part B. And for my class, this is classwork number 2 of 3. So this is something that's going to go on that sheet of paper that you're going to be taking a picture of and uploading to D2L. So go ahead and work y plus 1 quantity squared plus 81 equals 0. Give it your best shot, and then I will go ahead and pause the video and then I'll show you the solution. All right, so here we go. Hopefully you have worked out this problem on paper, and we'll see if your instincts are right. Subtracting 81 from both sides, we get y plus 1 quantity squared equals -81. And then by the square root property, if you have a quantity squared equal to a number, then you can say that that mystery number y plus 1 must be plus or minus the square root of that number. Now, in this case, we're taking the square root of a negative. So what do we do about that? we write it in I notation. So y plus 1 equals plus or minus I times the square root of 81. Then we simplify the radical if we can. We can because the square root of 81 is 9. So y plus 1 equals plus or minus 9i. Finally, we have to get the y completely by itself, so we're going to subtract 1 from both sides. So we get y equals negative 1 plus or minus 9i. These are not like terms. One term has an I, the other term does not. They're not like terms, they cannot be combined. You can write the answers separately by putting negative 1 plus 9i and negative 1 minus 9i. And those would be your final solutions. Here's another example. We have 3 times the quantity x minus 1 squared minus 21 equals 0. When you see that you have a quantity squared like that, with a variable inside and no variables anywhere else in the equation, that's a good indication that you can use the square root property to solve the equation. All you have to do is to get the quantity squared part in yellow by itself. So how do we go about that? Well, first we're going to add this 21 to both sides to move it over to the right. So we have 3 times x minus 1 squared equals 21. We're going to divide both sides by 3. Again, we're isolating that parentheses, that quantity that's being squared. And it had been multiplied by 3, so we're going to reverse that. So that'll give us x minus 1 squared equals 7. And now we have a quantity squared equals a number, so we can use the square root property. This gives us x minus 1 equals plus or minus the square root of 7, which cannot be simplified. 7 is prime. And so we're just going to isolate the x now by adding 1 to both sides. So we get x equals 1 plus or minus the square root of 7. 1 and square root of 7 are not like terms because there's no square root of 7 in the first term. So we're going to just write our final answer as 1 plus the square root of 7 times, and then 1 minus the square root of 7. Okay, this lecture is going to continue in the next video, where we're going to see that the square root property can actually be used to solve any quadratic equation, not just the ones of the formats that we've been looking at, by a process called completing the square. I hope you found this video helpful. If you did, please remember to give it a thumbs up. That helps other students to find the video.